Today we will be dealing with the PLL, how to configure PLL. Till now we have done PLL configuration in the IDE itself, right? But if you are given with an IDE where PLL configuration is not possible, right? Only for say example native IDE is only given, then you need to use this method in order to configure the PLL. So PLL you have already seen this block diagram. So here you are having system functions block in LPC2148. It is connected to two PLLs, PLL0 and PLL1. PLL0 is used for generating system clock. That is clock for CPU as well as other peripherals. But PLL1 is dedicated for generating USB clock. And always the crystal oscillator frequency which you are giving to the system functions block should be within the range of 10 MHz to 25 MHz only. And it can be multiplied up to 60 MHz. Core clock can be multiplied up to 60 MHz. And the USB clock will be always 48 MHz. So we have seen. So this is the equation for calculating the M value and P value, because in PLL you can see one M factor is there and one feedback division factor is there. Right. So this is the equation for calculating the M value and division factor P value. C clock equal to M into F oscillator. F oscillator should be within 10 to 25 MHz. C clock can be from 10 to 60 MHz in the case of 2148. Depending upon the controller, the maximum frequency will be different. And for calculating P factor, there is a frequency, there is a current controlled oscillator which is multiplying the frequency. That equal to C clock into 2 into P. P and FCCO range will be from 156 to 320. So this was the two equation. And this is how we are performing the calculation of M and P value. Let us consider F oscillator equal to 12 MHz. Right? By connecting this F oscillator, I need to generate C clock 60 MHz. So what will be the value of M? M equal to C clock by F oscillator. So 60 by 12 will be 5. So directly you will get 5. For calculating P, first of all, you need to substitute the C clock as 60 MHz. Then FCCO, you need to substitute the minimum frequency. When you are substituting that, you will be getting a value like this. After that, you substitute the same FCCO with the maximum frequency possible. So, you will be getting another value. And the integer value lying between these two can be configured for P. That will be the value for P. So here the integer value lying between this will be 2. So I have told PLL0 is used for generating system clock. System clock means it is inclusive of core clock and peripheral clock. Peripheral clock is nothing but VPB clock. PLL0 will be used for generating C clock. From the C clock you are deriving P clock or VPB clock by using a block known as VPB divider. Right. So now I have configured C clock as 60 MHz in the previous step. In this step you are going to configure the P clock. How will you configure? By using VPB divider. So for configuring this block, you are having a register known as VPB divider. By configuring this, you can configure P clock. Right. So only 3 configurations are possible for P clock. P clock can be either 1/4 of processor clock, or it can be same as processor clock, or half of processor clock. Processor clock is nothing but C clock. So by default, P clock will be configured with what value? Reset value is 00. So P clock will be 1/4 of processor clock by default. So these are the steps involved for configuration of PLL. So I'm going to make this configuration. F oscillator is 12 MHz. I am connecting F oscillator 12 MHz. I need to generate C clock 60 MHz and P clock 15 MHz. That is 1/4 of C clock. So what will be the first step? First step is you need to enable the PLL but disconnect the PLL from CPU and other peripherals. You are enabling the PLL but you are disconnecting from the CPU. Why? Because once the complete configuration of PLL is done, then only you are supposed to connect it to CPU and other peripherals. Right? So now you are enabling PLL and disconnecting PLL from the CPU.
Sir, one question: how does PLL gets actually disconnected from the CPU? I mean,
No.
what would?
Tell.
Okay, sir.
For that you are having two bits are there in a register known as PLL0 configuration register. PLL0 configuration register. In this, two bits are there. Enable and PLL connect bit. This connection and disconnection will be done with the help of certain digital logic such as AND gates and other things. So you are having two bits here in PLL configuration. One is known as PLL enable and PLL connect bit. So in this step you are enabling the PLL but disconnecting the PLL. So what will be the value? 0th bit will be, what will be 0th bit? Value 1 and the first bit 0 because you are disconnecting. So what value you need to write into PLL0 configuration register, control register? 0x01. Right? So this is the first step. Second step, you are going to configure the M value and P value. For that you are having a register known as PLL0 configuration register. Previously it was control register. This is configuration register. So in the configuration register, you can see bit number 0 to 4, 5 bits are used for configuring M cell. That is M value. Bit number 5 and 6, 2 bits, it is used for configuring P value. So here I need to configure C clock as 60 MHz. So what will be the value of M? It will be 5. And what will be the value of P? It will be 2. So I need to configure M cell value as 5, P cell value as 2. How will you do that? So this is a table showing that. So in my case, this is for PLL multiplier value. I need to configure value 5. So what will be the binary value that has to be loaded? 100. 100. Next value is 100. So M cell value will be 00100 in order to configure M value as 5. Similarly, how will you configure P value as 2? So here you need to keep in mind in P value, you can configure only these 4 values. So what will be the P value? I need to configure 2. So what value should I write? 01. So for configuring P cell, you need to write 01. For configuring M cell, 00100. So what will be the hexadecimal value? 0x24. So when you are writing PLL0 configuration equals 0x24, you are configuring P cell with 2, M cell with 5. And here you should keep in mind F for 214X series, F oscillator will be from 10 to 25, maximum will be 60 megahertz. So maximum of M cell value possible in 214X is 6. Here it is given till. That doesn't mean that you can give up to 32. You can give only maximum of 6 because minimum F oscillator is 10. So only maximum 10 into 6 you can give. Maximum you can give only up to 6. That you should keep in mind. You cannot give 32, 31, etc. F oscillator maximum only 25 megahertz you can give, and C clock can be maximum only 60 megahertz. You cannot have more than this. Right. Mean maximum F oscillator is 25, maximum C clock is 60. That is provided by the manufacturer. If you are giving 10, then you can give 6. If you are giving 12, you cannot give 6. You can give only up to 5. So next step is you need to give something known as feed sequence. So feed sequence is nothing but say it is used for protecting the PLL configuration, right? Because once you have configured this M cell and P cell value, what will happen? Your PLL will be affected. That means whole CPU and the peripherals will be affected, right? So by mistake, if you are making some changes in P value and M value, what will happen? Your whole system will be affected. So in order to avoid that, they have given a protection mechanism known as feed sequence. So even though you are configuring this, after configuring this, in the next step, immediate step, you need to give this feed sequence. Otherwise, those value will not be accepted by the PLL. What is the feed sequence? 0xAA, 0x55. It should be given in the same order itself. And who is providing this detail? That is given by the manufacturer. It is something like a, say what I'll tell, it is something like a key, you can tell like that. It is used for protecting the PLL configuration. So once by mistake if you are configuring M value and P value, PLL won't accept until in the next step if you are giving this. This should be given, then only it will be accepted that. And we cannot give any other value, only this value should be given. Then in the next step, so you have configured the PLL. In the next step, you need to verify whether your PLL 0 has been logged on to the desired frequency, whatever frequency what you have generated, what you are trying to generate. You need to check whether PLL is trying to generate that frequency. How will you do that? For that, you are having a register known as PLL0 status register. In that 10th bit, it is known as PLOC bits. It is used for checking whether my PLL is logged on to the desired frequency. So it is same as what you have done in UART and ADC, etc. You need to wait until this bit is 1. If this is 0, PLL is not logged. If it is 1, PLL is logged. So you need to wait until this bit is 1. How will you do that? First of all, you need to split this bit. For that, you are ANDing with 0x400. So 4 means only the 10th bit will be splitted. All the other bits will be masked with 0. And you are checking whether that result is equal to 0. If it is 0, this condition is true. You will be waiting here itself. When it becomes 1, you will come out of this loop. So this can also be written with the help of exclamation. So when the PLOC bit is 1, will come out of this loop, and so you can identify that your PLL has been logged on to my desired frequency. Then the next step is you need to enable the PLL and connect the PLL to the CPU. In the first step, what you have done, you have enabled the PLL, but you have disconnected it from CPU. But here, once the PLOC bit has been set, you need to re-enable it and you need to connect it to the CPU. So what value you will write? Both the bits should be 1. 1, 1. PLL enable should be 1. PLL connect should be 1. So both the bits will be 1 and PLL 0 will be connected and enabled. One more last final step is that again you need to give the feed sequence. So this procedure will be specified by the manufacturer of the controller. It may be different in different controllers and the value also may be different. So here 2 times you need to give the feed sequence. One after configuring M cell and P cell value. Next one after the last enabling and connection with the CPU. So till now we have configured the C clock as what value? 60 MHz. In the next step, we are configuring the P clock. How will you configure P clock? By using VPB divider. So in my case, I need to have P clock as 15 MHz. So by default, it will be 15 MHz. But anyway, you are writing VPB divider equal to 0x00. If I want to configure it as 1/2 of C clock, what value should I write? 0 to only you should write. 0x, it is not 0x10, it is 0x02. So that is how we are configuring the PLL. So this is a register summary.